So today we're going to talk about finding a slope if you're just given 2 points. Um, and that can be kind of difficult sometimes. Now you might ask, well, why not just create a graph? And sometimes you're given a graph, but let's see what would happen if we just looked at these 2 points and tried to connect them with a ruler. I see negative 4 comma 7, so I'm going to go to negative 4 on the y-axis and up to 7 on the x-axis, and I could make that point right there. I call that negative 4 comma 7. And then I'm going to go look for the second point, negative 7 comma 15. So on the x-axis, I go to negative 7, and then up to, oh no, I ran out of space. It's going to be up here somewhere, but without the grid, I can't really count how many steps it is, right? I can't really tell. I can tell it's probably going to be negative, right? It's going to be going down, but I can't really calculate the slope, right? I just don't have the tools. Now, also, if you don't have a grid provided for you, and you're just drawing the lines, you're just kind of making your own like this, then it makes it really difficult for you to be counting the slope accurately, right? So there is a way to do it without the Cartesian plane. Let's do it, right? It's not that difficult, really. What we need to do is keep in mind that we're trying to find the change in y, right? The change in y over the change in x, right? So change in x. And what you want to do is look up here and say, I've made these color-coded so you can remember that this is the x value, right? So in each coordinate pair, there's an x value, and in each coordinate pair, there's a y value. So just finding the change between them is not that difficult. One of the tricks you need to keep in mind is that this is, you want to kind of label these as, or keep in mind that one of these is your first point and one of these is your second point, right? And you may not know where they are on the graph, so it doesn't really matter. We'll just call this 1 and we'll call this 2. Okay, let me see if I can undo that scribbling a little bit. Right, we'll call this one 1 and this one 2. So let's take our first y. y1 is 7. I'll call that y1. And y2 is 15. And I want to find the difference, that's y2. And I want to find the difference between them, and of course that means we're going to subtract. Right, to find the difference between numbers you subtract. You might think, oh, I can't subtract a bigger number, but of course you can, right? You're old enough to know now that when you subtract, you're really adding the opposite. So 7 plus negative 15, I believe that's going to be negative 8, right? And now we're going to come down here and we're going to try and find the change in x, right? So again, it's important to do, we started with the y1, that's our first point, so that our first point here has to use x1, right? That's the first point that we're starting with. It's this one right over here, that first point. All right, so we're going to start with negative 4, and we're going to subtract negative 7, which of course would mean that we're going to add 7. Okay, instead of subtracting, we're going to add the opposite. All right, and negative 4 plus 7, I believe, is going to be 3. And you have just found the change in y over the change in x. That's it. So our slope, in this case, between these 2 points, is going to have a change of negative 8. Well, I write it like this. Let me get my eraser going on here again. Erase, draw. It's going to be negative 8 thirds. Negative 8 thirds. So let's just go back and see. I'll go back to our grid and just check and see if this method actually works. It looks like the change in y is going to be minus 8. 1, 2, 3, 4, 5, 6. I was probably off when I drew this, right? And the change in x is going to be 1, 2, 3. So I was really off when I drew that. Maybe we can do a little better job of it now. Let me erase this and see if we can get our points better. All right, so change in x, we'll just do the x first. 1, 2, 3. Does that get us to negative 7? That's 5, negative 6, negative 7. Yep. And then we're going to go up 8. 1, 2, 3, 4, 5, 6, 7. Oh, it's off. It's really off. So in this case, I really needed this strategy, right, of just changing those two, or finding the difference between the 2 points. All right, let's try another one here. Oh, is that the last one? I'm going to go this way. All right, let's try this one. Again, finding m. We're going to go change in y over the change in x. All right, so let's start with y1, and we'll subtract y2. All right, easy enough. 2, I should be using green here. 2 minus negative 8 is going to be 2 plus 8. So that gives us a change of 10. That's a pretty steep slope. All right, let's find, well, I don't know that. It's just a high number. Let's just find the change in x1 and x2. So 3 minus negative 2 is going to be 3 plus 2. 10 over 3 plus 2 is 5. Oh, well, that's not so bad then. That gives us a slope of, switch colors here, m equals 10 divided by 5, 2. That gives us a slope of 2. So, again, let's just go real quick and check. I think both of these will be on our grid, so it'll be easier for us to check. I'm going to go to 3, 2. So 1, 2, 3, 1, 2. There's our first point. 3, comma 2. And our next point is negative 2, negative 8. So negative 1, negative 2, 5, 6, 7, 8. Should be right there. That's negative 2, comma negative 8. And before I connect those two lines, I'm going to see, right, because that's a change of 10 and 5 between these 2 points that were given to us. That's a big one. Our slope of 2 should give us some other points, right? So it's a positive 2, so I know I should be going up. So let's just start here. We'll say I'll go up 2, 1, 2, over 2, and that should be another point on our line. I'll go up 1, 2, and I'll go over 2, and that should be another point on our line. Up 1, up, oh, you know what, I'm messing up. Mr. Meyer, that's embarrassing. Remember, this is a slope of 2 would be a 2 over 1, right? So our change in y would be 2 and our change in x would be 1. So up 2 over 1, that would be another point on our line. Up 2 over 1, that would be another point. Up 2 over 1, that would be another point. Change y by 2, change x by 1, that's another point. Change y by 2, change x by 1, and there it is. That's our third point, or our other point that we were given. So it looks like even though our 2 points gave us this giant slope of 10 over 5, if we take the smaller slope of 2 over 1, the proportionate baby steps, we could take this giant step of 10 over 5, or we could take these baby steps of 2 over 1, 2 over 1, 2 over 1, 2 over 1. All right, and either way, we found that slope by finding the difference between the first y and the second y, the first x and the second x. All right, we'll do another last one real quick, and we'll get out of here. Oh, it looks like we started with the hardest one first. Sorry about that. These last two are pretty simple. All right, so let's just get into it. Let's not even look at the graph real quick. Let's just find our change in y. And I should color code these, I apologize. So our change in y is green, right? Change in y over, my change in x, right? So let's get back to y. The difference between 2 and 6, and you can probably tell that that's going to be negative 4. And let's find the change in x. That's going to be 0 minus 4, and that's negative 4. Oh, so that gives us a slope, an m. A slope of negative 4 over negative 4 is basically 1, positive 1. M equals 1. So real quick, we can just say there's our y-intercept, right? So when x is 0, y is 2. That's just a coincidence that that was the y-intercept. And 4, 6. So 4, 6 is right there. 4, comma 6 is right there. Let's see if our slope of 1 actually works. It's a positive 1, so I'm going to go up 1 over 1. Great. Y changes by 1, x changes by 1. Great. Y changes by 1, x changes by 1. Great. Y changes by 1, x changes by 1, and we land right on our point. So these do all line up as we'd expect them to. It was positive, and they went up with steps of 1 over 1, or a slope of 1. All right, good job, everyone. Do great. Bye-bye.